So I'm going to go ahead and hit done. And where it's at is actually the settings for the graph. Notice that my diagnostics are toggled on. That's the only way you're going to get your R value. So if you don't see your R value when you perform these steps, make sure you go back to that gear and turn it on. Okay, let's go ahead and talk about those numbers. First of all, you do have an equation in slope-intercept form. Y equals 0.25 and something x plus a negative 492.898. On your packet where it asks you for the line of best fit, what you need to do for this line, let's go ahead and just make it easy. This is y equals 0.25x minus a 493, and I just rounded that to make it easier to graph but have significant digits enough to make sure my graph is correct. The next thing we're going to talk about is the correlation coefficient, which is R. I hope you have not written this down because that is not R, that is R squared. So what we're going to have to do is we're going to have to go to Add Calculator. So now that I add a calculator, I'm going to pull up the square root symbol and type in that R squared. Once I hit enter, that right there is the correlation coefficient. And let's go ahead and round our correlation coefficients to the hundredths. So for example, 3, when it asks for the correlation coefficient, you are going to write 89 hundredths. Okay, let's move on. I'm going to go back to the graph, and I did say that the correlation coefficient was 89 hundredths. Make sure that it's positive because that is a positive trend line. Let's go ahead and talk about example 3. So remember for example 3, this example right here had a positive correlation coefficient. Okay, let's talk about example 4. What is the scenario for this table? I will tell you what the scenario for this table is. This is hours spent on a tablet or online gaming and the score that you might make on a test in school. So we are going to take this data, and again we're going to go to the calculator on List and Spreadsheets. For the A value, we're going to type in X, and the Y is going to be for the scores. I'm going to key in this data super quick, and then we're going to go over once again how to find the correlation coefficient. Let me key this in real quick. Half hour is a 92, 2 hours is 53, 1 hour is 75, 0 is a 74. Okay, so remember, after you went to add data and statistics, notice how my screen turned pink, which is the color of the icon. The next thing you do is you anchor your variables, and your data will move according to the variables. And then from here, once you anchor your variables, this is where you go and hit Analyze. And after you hit Analyze, we are going to show linear regression, which is the first one, which is in slope-intercept form. All right, and there is our trend line, and there is our correlation coefficient squared. But remember, we do not want it squared. We want the square root of that. Oh, my battery. So let me go ahead and look at that, and then I'm going to go to a calculator and take the square root of that. So now the square root of that is a 36 hundredths. So that correlation is weak. It is below a half. That is considered weak. Now if you went back to the graph, that is a downhill line. So for example 4, when it asks what the correlation coefficient is, you need to write a negative 36 hundredths. And that's it for example 4. For example 5, we are actually not going to have time to talk about that, so I'm going to move on to the steps of a calculator. So when you go to write the steps on a calculator, you might have to hit pause because I do go pretty quick, fair warning. So get your pause finger ready. Here we go. All right, so number 1, new. Number 2, list in spreadsheets. Number 3, this is where you input your X and Y labels and input your values all the way down. Remember, your X and Y labels go on the actual tags, and where the cells are numbered, that's where you key in the data. Okay, so I've got my data entered, and the next thing I'm going to do is I'm going to hit Add Data and Statistics. Then I'm going to anchor my variables. So I'm going to select my X and Y axis. Remember, before you move on, you got to make sure that that diagnostics is on. Number 7, you hit the toolbar, then you hit regression, then you show linear, which is MX plus B. That's how you get your line, and more importantly, that's how you get your data. And don't forget, step 10 is to find the square root of that value. And in order to find the square root of that value, you add a calculator. I'm just going back because that's going to be it. So this was really over studying and SAT scores. And studying and I'm sorry, is it SAT or ACT? I think it is SAT. That's kind of a causation. So we need to talk about what causation is. Causation means that a change in the one variable results directly from changing the other variable. For instance, the more you study, the higher grade you get. In that case, it is reasonable to expect that this data right here is a causation. Let's go ahead and look at some examples. Let's say we have some data of the number of hot cocos sold at Starbucks and the temperature outside. That might be a causation. The colder it is outside might increase sales at Starbucks for hot cocoa. So we can say that is probably a causation. Let's look at the next one. The next one is going to be the number of Spotify subscriptions, which is a music service, and the number of Jagbucks Harrington passes out in class. Nope. Although Miss Harrington really does love music, listening to playlists does not enhance the number or does not increase the number of Jagbucks that she passes out. So there is no causation there. Next one, the number of firemen at a large forest fire. So this can get a little tricky. If the forest fire is really large, the number of firefighters at that forest fire might increase, but it's not a causation. One of those variable statistics does not affect the other. In other words, the more firefighters that go to the fire does not make the fire bigger. So that would just be an association. Correlation versus causation. Let's go ahead and just kind of recap what we talked about, and then we're going to call it quits. A correlation measures the relationship. So again, we have a positive relationship here. The X is the number of cars you buy, and the Y is the number of the money that you spent. We can also say that is causation because you got to spend some money to buy the cars. The more you pay, the more money, or the more you pay, the higher the car is, or the more cars you have. Remember, this is a negative correlation. So let's say X is still cars, but now Y is your bank account. So the more cars you buy, the smaller the account you have in the bank. The last thing we want to talk about is the correlation coefficient. And this one's pretty important. Just remember that the values for R range from a +1 to a -1. It's not going to exceed that range. And remember, you can have fractions that just indicates a weaker correlation. And remember, 0 means no correlation. And that's it.